Okay, okay. So, I checked on my cat, tried to figure out what he wanted. If you look at the video I just started making, I had to leave and come back. So I'm back now. So okay, so I kind of explained like the very lowest level interaction with the computer machinery. Kind of the highest level interaction with the computer machinery today is kind of just speaking to it in English. To the AI stuff right now. As everyone says, like a teacher will tell you, like if you like just like if you use a calculator and you don't learn to do arithmetic, then you have not learned to do arithmetic. So that applies the same as just uh, same idea. So and but this mid level the mid level programming language is uh, like to understand this to really understand the C programming language, you do kind of really have to understand the machinery, but it is not machine code. It is a programming language. So what is it? The C programming language. And why is it called C? Is that like a grade in a class? Like I think I think C. I don't think it's a grade in a class. I think it probably means it's the third programming language that was ever made or something kind of. It's really from like the early 1970s. In the early 1970s, the point of the C programming language is that it is a mid-level programming language. It's not just ones and zeros. It's not ones and zeros. It's not you know there are another way of like really the a human being for this computer, a human being very much put in the ones and zeros, flipped every switch, read every light, just dealt with ones and zeros. But computer today, like people put in these mnemonics for like what they want the CPU to do, like a little as if pushing a button on a calculator, kind of, and that's still machine code. But the C programming language is not machine code. It's meant to be human readable. It's meant to be human readable and but very close. It's very close to low level the low level machine language. It's not far away from the low level machine language. It's this where this says it's the definitive example. Somehow we go through these different phases through uh, computer history. Like these things happen through computer history, and the C programming language kind of has stood the test of time. Like at least to it still does. It does today, and uh, there so it you know it the C language is just the definitive example of like something that is not machine code, but it's barely more than machine code. It's so it was made for these the Unix programming environment, the Unix operating system. So so a computer, like a computer, you know I mean, I'm sitting at a computer right here. Like this is what kind of what people think of a computer, and yeah, that's what a computer is. So you know, uh, when people were thinking about how a computer should work and stuff, the first so a computer was a job for a person. Like a very long time ago, a computer was a job for a person. It was a job that someone had where they did arithmetic, basically. Like that when there was like a need for a lot of arithmetic to be done, and somebody would be paid to do it and just paid to sit there and do all the arithmetic. And the person's job, that was a person called a computer. The person was computing the arithmetic. And so then there were machine computers, and machine computer had an operator. So there was someone operating the machinery. Other people would like bring stuff to the operator, like they would bring a program or something to the operator, and the operator would handle like running the machinery. And then people thought like what if the computer has an operating system? So well, like when I was a kid, there was DOS was a really common operating system, and DOS was very simple. Like you would turn on the computer, and there would be a DOS prompt, and you would type in a program, and the machine would switch over to the program and run the program until the program ended, and then it would go back to DOS. And so it became something people say a lot, like multitasking. Like somehow this idea of multitasking became like something everybody says, like, oh, I multitask very well. When they're, why should I hire you? Well, I multitask very well. And so, I mean, so DOS was not a multitasking operating system. In DOS, you would type something. In DOS, you would turn on the computer, you would boot into DOS, and you would type the program name. It would run the program until the program was done, and then go back to DOS. And so, operating systems that do multitask, you run a program, and the operating system type starts to keep track of the program, and you can launch a bunch of different programs. You can have lots of different programs running at the same time, and they are all within the context of the operating system. And to the operating system, they're different contexts, and so it switches between them all like very quickly. It's like on a very old computer, it even a very old computer would switch between the different contexts like hundreds or thousands of times per second, and so it was keeping track of all these different things and like switching between them all really quickly, and a multitasking operating system. And so what does that mean? Like how should something like that work? Like how when you turn on a computer, like what should it do? Like that's that's still today, like a computer, like computers are just they're part of our world, and we just so but when you turn on a computer, it just like how should it even work? And so AT&T did a lot of they did kind of AT&T really kind of did a lot of research about like how telecommunications should happen and stuff, and like how should all these things work, and why should they work that way, and just uh, what they interestingly when AT&T AT&T, the history of AT&T is in the mid 1970s. The Department of Justice considered them a monopoly, and sued them about being a monopoly. They just owned just everything, every telecommunications thing, telephones, computers, everything in North America. Everything was owned by AT&T, and so AT&T went through these different phases of how they were gonna uh, succumb to the lawsuit of being a monopoly. So they did some different things. Like they had this Unix operating system. The Unix operating system, it was just it was there. I mean, so there were different types of computers. Like today, all computers are kind of personal computer. Well, I mean, what we all see are computers that we have on our desk or have in our hand, or like a personal computer kind of thing. And the Unix really was not meant for computers like that. Like there was an idea of how computers work that, and still kind of there are similar things today, but like a big computer, like one big computer in the computer room, like there's like one room of the office building that is just full of the computer and has one computer, and then at all the different employees' desks, there's a screen and a keyboard, and they type stuff and interact with the computer that's in the server room somewhere. And so, AT&T had made this the Unix operating system for computers like that, and was owned by AT&T and stuff. And so these various things happened, like as AT&T was being sued for just like owning every kind of such thing, just having a complete monopoly. First, they were allowed to keep all the they said you can keep all the telephone stuff, but you can't sell this Unix stuff. You can't sell it to people, or you can't sell it to people the same way that you're doing. And so, but they were allowed to sell it sort of to universities, and the people at the universities were like, "This is incredible. We should buy this quick. Like this is such a good. This is so amazing for us. Like AT&T's stuff is just like." They're not allowed to keep it for themselves, and they're allowed to sell it to us. We should buy it, you know. And so all these different universities like jumped at the chance to buy this stuff, and and study it, you know. And so the so that era by the mid 1980s had just that era in computer history was just that was how that ended, kind of. And so Linux is not Linux is this basically machines that are a computer, machines that are a computer, like like that. So if you're sitting at a computer, like you got a screen and a keyboard in front of you, like it's likely kind of um that's kind of hard to explain because Windows is kind of what people mostly see, you know, at least like sitting at a computer like that. And Windows also has stuff from Unix kind of in it, sort of, or stuff that goes back to Unix, that concepts that go back to Unix. And Linux was developed like right around, it was first released 17th of September 1991, and Linux was a complete rewrite for like personal computer type computers. It was a complete rewrite just from scratch of just like something very Unix like that was just a rewrite. It was a complete rewrite of just Unix basically, kind of. So well, that I mean that's kind of not there. It was the center, like the central component of like a free Unix rewrite. And today, you know, so what when you click something and like go when you go to a web page or something, you like here see this is wikipedia.org. These are Google windows I have open. When you're doing that, you're connecting to another computer somewhere else. Wikipedia is not just nowhere. Wikipedia is stored on the Wikipedia server computers. So when I type this in, I'm connecting to computer somewhere else. Like here Google.com, I'm connecting to a computer somewhere else. GitHub stuff like that, YouTube, and the most common operating system for a computer, including those and other things like is Linux. Linux is the kind of it became like the most common thing that I mean like it when any computer's interacting with any other computer, and so a lot of them you don't really see like you know, I mean, Linux is just, it became like, I mean, that's hard to explain because people are like, no, like, I know that's not true. Like, when, and so, well, so, when you're sitting at a Windows computer, the Windows computer like you sit at, compared to all of the different computers in the world, that there's a very small percentage of them that are computers like that. And many of the rest of them are just computers that are like in stuff, or computers that are on the internet, and they're just like so when you go and sit down at a computer somewhere, it's going to be a Windows computer usually, and not a Linux computer usually. But those computers, that's a small, kind of a small percentage of the computers that are just in absolutely everything, and like in server rooms and stuff. Uh, like their Linux is the most common operating system, and so, and this like GNU project, this like that that this all this stuff came from an era where AT&T had sold all that stuff to universities. So the like GNU is supposed to be, GNU's not Unix. GNU is specifically not Unix. It's like complete rewrites. Like Linux is an example of a complete rewrite of something. And so GNU is these things that are complete rewrites that are not Unix, but they're the same. They're rewrites that kind of fulfill or do kind of the same things that the software did. And AT&T continued this. Bell Labs was owned by AT&T. AT&T continued their research. This was kind of like where in the mid 1980s they kind of just in the mid 1980s they settled the lawsuit by becoming the Baby Bells. So AT&T settled the lawsuit by disbanding into a bunch of different little companies. This became owned by a company called Lucent, at least at that time. But this like the Unix type stuff from the AT&T people who did it. This is where it ended up, like the mid 1980s, like but about the mid about 1985. This was where they had gotten to like Unix type stuff. And so this at least like how it looks is, I mean, it looked about like this. I mean, by about 1990, I would say, by I don't know, but so this there are some things that really make Unix. So like the things that make a Unix operating system a Unix operating system. There's kind of these certain like things about it, like design choices of like how is the computer going to work and stuff, like how does it work. And so Legos, like in Legos, like a Lego set, like there's all these different things that click together. There's the different Legos, and they all kind of click together, and there's kind of some different ways that Legos click together in different ways. And but but Legos, like there's like an individual Lego is a thing. In the Lego toys, like everything is a Lego, every little thing is a Lego, and they click together in these different ways. You can put them together to build them into stuff. You put them together, they click together in these different ways, and you build them into like stuff. And so computers, computers kind of like the idea, especially for Unix, is that there are programs that click together and stuff. Like there's programs and everything's a file, and everything like clicks together and stuff in these certain ways. The the everything is a file thing is real. It's kind of hard to explain to people who are used to Windows, just because on Windows a file is like you saved something and it's there, and you open it, you delete it, whatever. A file is like there, it's something that's saved and you can open it and look at it later or something or whatever. And in Unix, that's not the same thing. Like in Unix, a file is a system object that you can open, you can put data into it, take data out of it. But in Unix, everything is a file means like it's not just like you like if you if you take a picture and it's saved as a JPEG, and a JPEG is like a stored file, you know. But on Unix, the webcam could also be a file. So you have like this, like a device file that's the webcam, and you double click it, open it, and it's a JPEG. But it's a JPEG that's immediately a picture taken from the webcam, and so like everything is a file. Like on Unix, stuff would work that way. Like you would have like a special JPEG that's a device JPEG. You double click it and open it, and it's a, you know, it's whatever the webcam, whatever's in front of the webcam. And so on Unix, like everything is a file. You know, this, you know, when I kind of just like, when I don't know, this, you know, I get paranoid too. Like we all get paranoid. Like we have these cameras and everything. Like, can you see me? You shouldn't be able to see me. So okay, just, you know, computers, they're so like, you know, like they're these kind of like, you know, how does it really work at every, down to every like one and zero? Like I'm supposed to like, if it was like very, if it was very secure and I knew what was all going on, shouldn't I know what every one and zero, if I, there shouldn't be a one or zero out of place anywhere, right? And there is, like there's so many just like, oh, just like, and people, you know, computer security, some like that, you know, just something kids are very interested in. Like, wow, you mean like destroying the computer? Like, yeah, like wow, that's so interesting. And like in academia, people are like, okay, like we can't even avoid, you're just like, you know, that fascinated with that, like that. I mean, is that like, you know, like robots in the future versus humans in the future? Like who's the bad guys, you know? So, but anyways, and I mean, like, I mean, if the robots are made by humans, it's probably the robots, you know? Like, damn, that's really, wow. So, but, and, anyways, so, there's these, like, programs and stuff, and so here, I'm really running, three different operating systems here. So, and so there's this, like, the Unix name command. So we'll say that. Okay, so there's like that, this output, and there's also this, commonly this like OS release, file, and so this is Alpine Linux. It's a type of Linux. Then here is, the, and see how this says Linux, but it doesn't say GNU Linux. So GNU, there's kind of reasons that, the GNU project is a mass collaboration. That's like a very good way to just like describe it right there. A mass collaboration, and many people contributing all these different things, and it gets kind of overcomplicated kind of quickly. So so sometimes people go and rewrite things just to like be simpler, like that. Just go rewrite everything so it is not a mass collaboration and it's just simpler. Or there's other reasons people rewrite stuff for different reasons. But this is, Debian Linux is almost like the definitive GNU Linux, and Debian's like a very old type of Linux, and it's very GNU, and that's okay. Uh, and then Plan 9 is really, Plan 9 is really a different operating system. It's not, like it's what a it's kind of comes from that, like directly from the AT&T stuff, like Unix, AT&T Unix. It has the uname program, but it's in like a compatibility, the ANSI POSIX environment compatibility stuff, and so if I type that, it's just it's something. It's a different OS, and so there's kind of reasons that the different OSs have different like strengths and weaknesses, and so and then what about Windows? Well, there's this like Wine is not an emulator Windows compatibility layer, and I was gonna use that to show you something too. And so the cat is really he's really he's been watching the news and he gets upset. So so there's a very common there it's a program that's like on any time you're like typing to the computer, there's almost always something called Echo, the Echo program. So let's just type Echo and see what it does. It seems to do nothing. We type Echo and it does nothing. What if we say Echo hello world? It does, so do you see what it did there? Echo 1, 2, 3, 4. Echo blah blah blah. So Echo, when you type Echo and then you type something, then it says it echoes it back to you. It just says something back to you. So I introduced the cat program here without even mentioning it. The cat program. So cat. If I just type cat and then type hello world, it says it back to me too, but it's different. See, it's still running. Well, how do I exit? Well, and so there's kind of two different ways, there's especially like the end of file character is you would usually type that by typing Control D. So if I type Control D, it's like the input has ended and the program exits. And a program can also be interrupted, and that's different. So if the program's running and on Linux it's Control C, Control D, I'll press Control D, and it completes the input. Control C does not complete the input; it just interrupts the entire thing. And so Control C just interrupts the entire thing and it exits. And so the cat program concatenates either it's the input to the output, can concatenate the input to the output, or files. So when I did this, there's this file. It's a storage file in the system, and when I type cat and it concatenates the files, the file names to standard output. And so if I do it like 3 times, then I've concatenated the same file 3 times to the standard output. And there it goes. See, it did it 3 times here. It did, So, and also if I do like echo hello world, or let's see, I mean, it's I'm trying to think of a good way. So there's a lot of different programs. There's a lot of different just like programs that do things. So grep is a program that grep finds stuff in the input, and so it finds stuff in the input and that stuff it puts to the output. So if I grep blah, then let's see. So now if I say hello world, it just says nothing. If I say 1, 2, 3, 4, it just says nothing. But if I say blah blah blah, then it's found blah, and it does put that to standard output. And the uh, you know so these programs are they're like Legos. They're concatenated, or I mean the programs can be put together in different ways. So like this is a loop. So actually this program true seems to do nothing. False seems to do nothing. But they they did something different. Like their return code, true returned success, false returned error, and it doesn't even show anything. But so there's also like syntax to do stuff. So if I said like uh, if false, then echo hello world, and then fi is end the if. So let's see what that does. Nothing. It does nothing. What if we say if true, then hello world fi, then echo hello world fi? It does. If so, true is true, and false is false. And so we could say while true. While true is like a loop. Like as long as true is true, then do date, prints out the date and time, sleep for 1 second, and then done. So let's see what that does. And I think you can guess what that does, but it does. So every 1 second it prints out the date and time. And this when I want to stop it, I have to press Control C now to interrupt what it's doing, and it'll be done. And so there's the different programs that I showed you there. I showed you echo, false, true, cat needs, and then date, sleeps for however many seconds. So let's see, sleep for 3 seconds. 1, 2, 3, and then it's done. And then these other things, the while, if, those are like syntax to put stuff together. So and programs can be like they can be connected together and like snap together in these different ways that are kind of like Legos. Everything's a Lego. Legos snap together in these different ways, and they're different Legos that do stuff. And so like this, like right now, like what's this about? Is this you? Say hello, hello, hello. What's going on here? So it's like Firefox is using lots of computer. So anyways, and so this wine is not an emulator runs Windows stuff. And so it's just something I was thinking, as I'm going to show you as an example. So like I thought, like, okay, what are very, very simple examples of these different programs? So the Echo program is a good example of something to show you. So Echo 1 2 3 4, it echoes 1 2 3 4. That's all. That's what Echo does. But this is the GNU. This is the kind of definitive GNU version of the Echo program. And when we look through the source code here, it's had many different. It's it's got the authors' names in it. It's got. I mean, I don't know, the GNU code. It's just. I mean, I don't know. I guess it's kind of an opinion, but this is the Core Utils like main GNU Echo program, and that's kind of this is kind of characteristic. Like this is GNU C code. It often kind of might look something like that. then this OpenBSD. I am not running OpenBSD here. OpenBSD is the regents of the University of California had bought the AT&T stuff. The students continued, kept going with it, and OpenBSD eventually was supposed to be. OpenBSD was supposed to have all this like security stuff, like research all this like stuff to make it as secure as possible. If people really are, I guess like if you if you want to learn about computer security, OpenBSD would be good to learn about. For example, there's these certain things that are just like system call functions, like this pledge standard input output. The OpenBSD has this thing called pledge, and OpenBSD, like, they added this at some point. I think I remember when they added this, but they pledge this program starts and it pledges that it's only going to use standard input and output. Then the program continues. If the program does anything that is not that it has pledged that it would do, the program will error out. It'll say like, "Wow!" Like the operating system will stop the program. Will say like, "You pledged that you weren't going to do that." And so that's the OpenBSD version of the Echo program. This so if I'm this kind of the simplest possible Echo program. So first of all, I'm talking about Echo like you would type here, and there's something kind of different. So this is the simplest Echo program that we could possibly, or actually, I think an AI wrote this. So what we can do here is cat this into our own Echo. The cat program just, first of all, the cat program, when I type something into it, it's going to output it. I'm going to redirect the output to C source file on storage that I'm going to call echo.c. And then I'm just going to paste this and press Control D. And so now this CC is just a C compiler, CC echo.c, and now we should have a file called a.out, and that seems to be what just got created there was our a.out file. And so now this a.out file is an Echo program. We can mv to move the a.out file into a file we call Echo. And so now we have an Echo program just right in this right here. So this is our Echo program, Echo blah, and so Echo blah, and this I mean it's the most minimal Echo program that we could have come up with. And Echo usually has it usually at least has E and N flags, and those it usually at least has those. I don't know. So yeah. Just anyways. So the Echo dash N Echo dash N is no new line. So Echo dash N and blah blah blah. See how it just like it didn't put a new line at the end. Like now I'm right here. Like what? I'm right there, not on the next line. So blah Echo. See, that's different. With the N dash N, it doesn't do that. And dash E prints special characters. So I don't know. I'm trying to think of one. So I think a special character. Well, backslash N. So Echo dash E Backslash n is a new line. So I could say echo dash e backslash n. I could do a bunch of them. See that if I did a bunch of them, it just echoes a bunch of new lines. And so and this is this is commonly, so the C programming language, this include is to include standard input output. Like many computers have this concept of something where you type here and type commands and put them together into stuff like a command line. Many computers have that concept of a command line, and there's a very standardized ways that is done in C, but not necessarily. An operating system might even have the C programming language and not have this. It may, and just so you would not this in the C programming language, we're including the STDIO standard input output. That is the C, it starts including stuff. This printf function is part of the standard input output library. Printf is not necessarily part of the C language, and that's kind of a distinction. Like, that's kind of a strange distinction to tell people, like, because C programmers would be like, C programmers who are accustomed to command lines like this, they would all know the printf function. But C programmers may or may not. They may not be working in an environment like that. And so that's like our simplest implementation of Echo that doesn't have any flags or anything. There's something different. An Echo server is like a server that when you connect to it, you connect to it and send something, and it sends everything back to you. And so, but this shell script Echo, so the shell script Echo, that's what I'm talking about here. This hello world, where we've run our Echo program like that, like hello world. And also, I told you this concept, like everything is a file. So there's device files, there's device files, and there's like the folder where there's the file descriptors. So 0, 1, and 2 are always open just by default. So it's kind of just a lot to explain. So anyways, there's let me see here. So VI is an editor. So let's edit our Echo program. And let's say I don't want to use the stdio library. I want to use the UniSTD now. It's just like this standardized it's just standardized stuff that's kind of simpler stuff. So let's see. First we say we need a variable int length. So we're going to loop over these arguments. So we're going to set our length argument to 0, and then while this parameter and length is not equal to the, it's like, so I should explain what I'm doing better, but okay, I will once I've done this. Okay. Oh, whoops. So, so I've rewritten this program here. Let's see if this compiles. Okay, and then move our a.out program to echo. Let's see if it works. And it does. It does seem to work. It seems to work. Okay, and so I rewrote the echo program to not use the standard input-output stuff. The standard input-output stuff includes a bunch of stuff, and I wanted to leave all that stuff out and make it a simpler like, or closer to just less stuff included, basically. So there's something like almost always there's this concept of write and read, and that they're from file descriptors, that these, or well, I'm not even saying this right, but the write function is like an operating system function, or it actually is, I mean, kinda, at least. So write, what I've done here is I've made it a simpler like so this is a minimal, the most basic implementation. This is the most basic implementation if we have the standard input output stuff, and I rewrote it like the most simple if we did not use the standard input output stuff. And the standard input output stuff has these file descriptors 0, 1, and 2. It always has 0, 1, and 2. So printf always puts to file descriptor 1. The file descriptor 0 is file descriptor 0 is the input. File descriptor 1 is the output. File descriptor 2 is file descriptor 2 is output that does not get used by other programs. And these programs can be put together, and the programs can be like chained together, so that inputs and outputs, like the outputs go to the inputs and stuff. So now let's say we want to say an error message. So once we've printed our error message, and then we want to grep for the word blah, and we don't get it. It doesn't go to grep. So, but let's do this. Blah blah blah, echo blah blah blah, and we're so this pipe character, we're setting the output to the input of grep, which is blah, just like this. I don't know this. So I don't know. I just got very this. I had started writing like a textbook kind of thing, which I didn't have a link for you here. So anyways, this is let's see, the Plan 9 version of the Echo program. So this, we've got these 3 different examples. This is the GNU example. This is the OpenBSD example, which is it has the E flag, the N flag, and it has extra security stuff. And this Plan 9 version, it does have the N flag. It doesn't. I don't think it has the E flag. I don't see that anywhere. Nope. But it's meant to be kind of simpler. It's just, the idea is that it's like simpler, and I mean, it's just, I don't know. That's the hope, that it's simpler. So, but what about Windows? Like on Windows, we commonly are not talking about stuff like this. And when a system is designed, like what goes into a system design is kind of this idea of like everything is and on Windows, everything is a window. It's kind of like everything is like in Legos, everything is a Lego. in Unix they say everything is a file, which is it's kind of hard to explain. That a file is like a system object, and like in Linux there are so many people who don't really understand what somebody said there that it just doesn't work that way. It does not work that way. Plan 9 people understood what they said, and they in Plan 9 it is the case. Uh, but Windows, uh, so on Windows everything is a window. Everything is a window. That's like the um, on Windows everything is a window. So so I'm gonna make a like an Echo W program that is a the Echo W my Echo W program is going to be kind of like a Echo Windows program. So let's see. So first of all, we're not going to use that. We're going to use this include windows.h. Include when I'm including the Windows system library stuff here. Include windows.h. And so length. So for this I'm gonna actually I'm gonna move this outside of the loop first. Length. So the length is gonna start at 0, and then I'm gonna loop over all the stuff. I'm not going to write it out to output, but I'm gonna add one more here for the length if it or even regardless, and then have one more length here just for this is the total length of all the bytes that are characters to my parameters to my program. So like this, if you really want to follow along with what I'm doing here, I had started writing something. I almost was like, wow, I'm writing a textbook, and then I'm not writing a textbook here. I'm making a YouTube video. So I think maybe I'll try to put the textbook back online and just like work on the textbook. But this is the definitive textbook for the definitive mid-level language. And when you look at this textbook, the first edition was printed in 1978, the second edition was in 1988, and there's a bunch of stuff that just doesn't work the same anymore anywhere. It just doesn't work that way anywhere anymore. And so, but anyways, so what I'm doing here, this length, I'm counting all the characters here, and storing them as in like this length integer. This integer length. Initially, I've started at 0, and then I'm looping over all this stuff. So the length of this echo. So the length of this, if I just type echo, is actually 1, or no, it's 2, because it's a new line, and then at the end of all these things, we always have like a null terminator, like a byte that's just 0 value. And so that when I just type echo, if I just type echo, it basically outputs 1 byte and then outputs a null terminator, which is kind of a special, like it's the control D byte basically. And so if I just type echo, but if I type echo 1, 2, 3, how many bytes are here? Well, here's 1, and a space is 2, 2 is 3 bytes, 4, 5, and then a new line, so 6, and then 7 is the null terminator. And so this is counting all those and putting them in length. And then we're going to loop over it again for int I equals 1, I is less than argc I plus plus. Or wait, we want to do something else here. In C you have to manage all your you have to manage your memory. You have to you have to deal with the machine to manage where all those memory store and recall things like that. You kind of have to manage all that stuff by hand, and you kind of have to really understand what the machine is doing and stuff to kind of understand that well enough. I mean, you have to understand that at least well enough to kind of understand what a computer does. And so I think I will need the standard library to use this. There's a function called malloc that is memory allocation the memory allocation function, and so I'm allocating length bytes of memory, and then if string is null is a special pointer that's like if string is null, then there's just an error, and we just we return -1 is an error code. It's really bizarre. Return 0 0 means success. Anything other than 0 is an error code. And so now let's see. Let's have another integer called position too. Or maybe do we need that? No, we don't. We don't need that. We're just well, it's more clear if we just have a different one, because length means length, position means position. So we have another integer called position, and so we start at position 0, and so while argvi sub position, let's see. Length equals 0. Length equals 0, position equals 0. Then, let's see. And we have I've allocated this thing called string, another thing that we're going to use here. So, okay, so let's see. I'm trying to think here. Actually, this should be inside of the loop. So, string at position length equals argv sub I sub position. And then we want to increment both of those. Length plus plus and position plus plus. We're incrementing both of those and continuing in our loop. And then, so I think all those would end up in there. Then we're going to say if, let's see, what did we say up here? I guess we didn't say anything. If I is less than argc minus 1, then string length equals the space, and then else string length equals, I don't know why we're doing this new line, because I'm doing something different with this here. Then let's see, now we increment length again, and then the final thing that we're going to do here is okay. The final thing that we're going to do here is append a null terminator. And then what something that we saw here. Okay, we're gonna make a little message box, a little Windows message box. So this is gonna be our echo W program to echo. It's gonna echo string. It's gonna echo our string, and the title of the window will be echo. So it's gonna be a Windows Echo program. So let's see. I wonder if this will work. Okay. Okay, wait a second. I just typed that all over here, but that's on here. That's not, it's on the other OS, so let's see. Yeah, there it is. Is that a program? Yeah, it is. Okay. And now we have our it's a.exe, yeah. It's a Windows program. So, and that's our a.exe program. Move that to echo w.exe. And then we say echo w.exe, hello world. Oh no, it's a Windows program. So we're gonna say we're gonna run it with wine. And there, see, it's an everything is a window. It's a Windows Echo program, and I think this might even like it. I think if we said like blah blah blah, or well, no, that's not what that would do. Wine echo or echo w.exe. Let's say the uname.a thing, uname-a, and so it's gonna. So this is another way of putting programs together. I put these backticks around the uname-a, and so it's gonna run uname-a, and so we type that, and it just and there. So it's a little echo window program, like just the way that a system is designed, like on Windows, everything is a window. This is like a compatibility, so we're running Windows stuff and running a Windows program on here. And so, yeah, that was so that's really kind of an example of like how how it's mid-level and kind of it can be kind of different on different types of computers and stuff, but it's I mean, it's like it's a language that it's very distinctively C, you know. Let's see. What did I do? What did I do with my? Did I didn't save my other echo.c program, but I copied it over from here. Like I think this might have been generated by the Google AI. So yeah, so yeah, I made a little Windows Echo a Windows Echo type program, Echo W.exe, and it like you know I could print the date and time. Oh, it didn't. I'm in the wrong window here. Could make it print the date and time, or something like that. So yeah. So I don't know. I feel like this video was very like rambly and just like I don't know. I started writing a textbook kind of thing. Maybe this is it. I don't think it is. I don't even know. I don't even know. Yeah. So, I don't know. How long is this video? It's a long, rambly video. Like, none of that even, I don't even know. If you, I mean, like, what, I don't know. Look at, if you just look up, I don't know, the C programming language, look up stuff about how to, there's all kinds of resources on the internet about how to program in C. The Unix programming environment has influenced everything that came after it, and so this is another textbook, another good textbook. And so, anyways, yeah, I don't know. I guess that felt kind of like lackluster and just like, yeah, whatever, dude.